Okay, in this video we're going to look at what's called solving all polynomial equations. Now, it's kind of deceiving by that title because really what we're going to be focusing on is how to figure out what kind of roots, what kind of solutions each polynomial has and how many solutions it has. For example, now if you write down this fundamental theorem of algebra, that's fine. All it's pointing out is that every polynomial of any degree greater than or equal to 1 with complex number coefficients has at least one complex number solution. It at least has one solution. Whether that's real or non-real, we'll talk about that in a little bit. But first off, to figure out how many solutions you have or how many roots or zeros you have, you look at the degree of the polynomial. That's what we talked about back in the first lesson for the chapter. Remember, that's the degree of the polynomial is you just look to see what's the largest exponent from each term, and whatever the largest exponent is for the polynomial, that is the degree. So if we're dealing with the quadratic equation in that form, ax squared plus bx plus c, it's going to have two solutions because you have an exponent of 2. Now, thinking back to chapter 6, remember we had this quadratic formula. And sometimes when we took the square root portion, sometimes you ended up with negative numbers, which resulted in non-real solutions. So we used a discriminant to figure out at the beginning if our answer would be real or non-real. If I used a discriminant b squared minus 4ac and I got an answer that was positive, it was greater than 0, that meant that we would have a real solution. However, if I got b squared minus 4ac and I ended up with a negative number where it was less than 0, that means the roots or my solutions were non-real numbers. Remember, that involved taking out an I, so that way we could take and apply the square root then of a positive number instead of a negative number. That was chapter 6. So that all they're saying there is that there are situations that we're familiar with already where we have two solutions, and sometimes those two solutions are real and sometimes those solutions are non-real. Now we also have this idea of multiplicity. Multiplicity is referring to the number of repeats of each root. So for example, if I have x minus 5 in parentheses squared, the root is going to be 5, because if I set x minus 5 squared, because if you think about it, x minus 5 squared means that we have x minus 5 times x minus 5. Well, if I set each of those equal to 0, they would both yield with a root of 5. So there's our answer for both of those. But I don't want to write down 5 twice. So instead, a better way to write it is that we would say we would have a root of 5 with a multiplicity of 2. Now, the multiplicity can be determined by the degree of the factors. For example, if I look at that x minus 5 in parentheses squared, I can see that it's going to have, since it's squared, it's going to have two roots of 5. Two of the same roots being 5. If that had been to the 8th power, that would mean that I would have a root of 5 with a multiplicity of 8, because there'd be 8 of them. So the degree of the factor determines what the multiplicity is going to be. So let's look at this other example. Here I have 17 times x minus 4 times x minus 11 being squared. We're going to try to figure out the zeros. So I'm going to set each of these equal to 0. Now, when I say each of these, the 17 we're not going to set equal to 0 because we don't get a 0 from just a plain old number. We get it from our x's. So each term or each part that has an x we set equal to 0. So I can see for this first one that I'd end up with a 0 of 4. If I add 4 to both sides, I'd get x equals 4. So 4 is a 0. 11 is also a 0, but we would say it's got a multiplicity of 2. So there would be your answer. So one of these zeros would be 4. You could say it's a 4 with a multiplicity of 1. And then we have another 0 being 11 with a multiplicity of 2. So that's multiplicities. So let's go back to talking about the degree and figuring out how many are real and how many are non-real. So we have, again, all numbers can be categorized as being complex numbers. So now those complex numbers are going to be either real or non-real, and those real numbers can be classified as rational or irrational. Now, rational and irrational numbers, that's what we talked about in the previous lesson, where we used the rational root theorem, because that allowed us to see which of our roots would be the possible rational roots, and then remember we use those to narrow it down to find out which of those rational roots were actual roots to the equation. But again, those just identified the rational roots. Sometimes there were roots that or x-intercepts, they would have zeros that didn't show up under one of them with our rational root theorem. That just means they're irrational. So we'll set that aside. Today we're just going to be looking at, again, seeing if they're real or non-real. The way that we do that is, first off, they say how many zeros does this function p have? Well, again, we look at the degree. The degree for this polynomial is 5, so there's going to be 5 zeros. So that means that there's a total of 5 complex numbers. So that means between my real and non-real numbers, they need to add up to be 5. So I could have maybe 4 real and 1 non-real, or I could have 2 and 3, or 3 and 2, or I could have 5 real and 0 non-real. So there's a lot of different combinations that we could have here, but to figure out what our answer is, we're going to have to go to a graph. So get out your graphing calculators, and we're going to graph out this equation. Now, if you graph this equation out, I've already got it here for us. X to the 5th minus x to the 4th minus 21x cubed minus 37x squared minus 98x minus 24. If you graph that, this is what we end up seeing. And if you want to zoom out so you can make sure that we are seeing the complete graph, we can do that. And I don't see anything else showing up, so I know that this is my complete graph here. So I have 1, 2, 3 x-intercepts. Remember, an x-intercept is the same as a root. It's the same as a 0. So I have 3 zeros, 3 roots that are real. That's what the x-intercepts implies, that those are our real solutions. So now, that means that since I have 3 x-intercepts, it means I have 3 real zeros. Well, if 3 of them are real, that implies, well, if there's got to be a total of 5, that means 2 of them are going to be non-real. That would be your answer. So that's a pretty easy lesson. So that's all we're talking about today, is just making sure we can identify, by looking at a polynomial, how many zeros there's going to be. And we can look at the graph to figure out of those zeros, out of those roots, how many of them are real. And then we can use that to figure out how many of them are non-real. Or if we see the factored form of a polynomial, we can find the roots just like we were doing before, but remember, now we want to identify any multiplicities. So if it's squared or cubed, that tells you what the multiplicity would be. So with that, good luck on your assignment for today.